In this video, we'll talk about solving multi-step inequalities. If you haven't already, I would highly suggest checking out the videos solving inequalities involving addition and subtraction, and solving inequalities involving multiplication and division, as both of those are foundational for the multi-step inequalities. So let's just dive right in. As we've talked about before with our videos of solving one-step inequalities, we have learned that we can treat inequalities much like we would equations, with the one exception being if we're multiplying or dividing by a negative number. And if we're looking at this example, negative 4x plus 7 is less than or equal to 12, the answer to the solution set, I should say, is not immediately obvious. What values of x work here? I don't exactly know. However, we can now trust our process. We can trust our ability to solve these things to give us an exact solution set. So just like we would solving an equation, the first thing we're going to do is we're going to kind of work our order of operations backwards. So I think our first step would be to subtract 7 from both sides. Now I can do that and still maintain the inequality. If I subtract the same thing from both sides, we're still good. So negative 4x is going to be less than or equal to 5. Now what we're going to do is we're going to divide by negative 4. Now, like I mentioned in the previous videos, when I'm dividing or multiplying by a negative, I'm going to put a star on that step for myself. That way I know I have to change the direction of this sign. So x is going to be not less than or equal to whatever this quotient is. It's going to be greater than or equal to negative 5/4, which I'm going to leave as an improper fraction. This would be my solution set, and if I was asked to plot this on a number line, well, we would say, okay, here's 0, we're going to go to negative 5/4, and then what we're going to do is we're going to put a solid dot there, and since x is greater than it, we're going to the right. And that would be an example of a plot for my solution set. So really, we can treat this just like we would an equation. We just have to be careful with any negatives that we may or may not have. If we're multiplying or dividing by positives, everything's fine. We don't have to change the direction. However, if we divide or multiply by a negative, that's where we have to really check ourselves. So let's take a look at one that's a little more complicated. In this one, we have x's on both sides of the equation, and it looks like or the inequality rather, and we will probably have to do some distributive property to begin this. So the first thing I'm going to do is I'm going to distribute on both sides, just to try and make it a little bit easier to deal with. So what we'll do is we'll say this is 2x plus 2, right there, and we'll keep the inequality because we haven't really altered anything yet. We'll have negative 3x minus 6 if we do that distribution. So this expression is represented right here. Our next step will be to try and get our x's on one side and our numbers on the other side of the inequality. And all things equal, I'm going to try and figure out what situation I can have to where I'm going to have positive coefficients on my variable. So instead of moving the 2x to the right, I think I'm going to move the 3x to the left. In order to do that, I'm going to add 3x to both sides, and the reason I'm doing that is that I know 2x plus 3x is going to give me a positive number. Now on that same token, I'm going to move my negative 12 to the right side of the equation. So I'm going to add 12 to both sides. And what happens when I do that is I will have 5x is greater than or equal to negative 6 plus 12 would be positive 6. And then we can now divide by a positive 5. I don't have to flip my inequality. I don't have to really think about, okay, do I need to change things? And that's all things equal. That's why I chose to move the negative x's over to the positive side to maybe give me a result in a positive coefficient. So then x is going to be greater than or equal to 6/5. And again, if we were to put this on a number line to make the plot, there's my 0. I'm going to go over to 6/5. It's greater than or equal to, so we'll have a solid dot, and it will go off to the right because it could be greater than. So there's my solution and the plot, and the idea is we can treat these things exactly the same, with the only exception being if I'm multiplying or dividing by a negative number, I flip the inequality. Other than that, it's just like we would do if we were solving equations.